question is clone graph. So they're giving a reference of a node in a connected undirected graph. Return a deep copy of the graph. Yeah, so for the graph question, normally we have BFS and DFS, two solutions. So for this question, I try to solve it by DFS and BFS. So when we meet a value in the old graph, we should create a counterpart. And after that we could go to the next neighbor, and we could go to the next neighbor. For the neighbor, we also create a new counterpart, and for the neighbor's neighbor, we could go to the create a new counterpart. Yeah, so yeah, that is the DFS. Another way is we create this is the entry point. We create this one and this one. After we create these two neighbors, and then we put the neighbors into a queue, and we pop out the queue. We put the neighbors into a queue, and we go through the queue. Yeah, you can see. Actually, we have for the DFS, we also has two solutions. One is the iterator. That means we go through this node one by one. Another way is looks like divide and conquer. We process the first one, and we assume this one already processed and this one already processed. So that make code very clear. It's better than the iterator method. So that is the divide and conquer method, DFS. So if it's none, we should return none. So that is the we can use the Hashi map. That is very important. Is we should do mapping from the old node to the new node, from this old node to the new node. So we need to a Hashi map to do that, because if we already, such as for this one neighborhood is 2, when we do the node 3, we also already create this node 2, so we just get the node from the Hashi map. Yeah, so that is the Hashi map, and we do the if the BFS or divide conquer, we have we should use the incursion or inclusive method. So that is that if it's in the old, if it's already in the old, we just return, because we already process this node. If yeah, so because we have it's a graph, so it's not a tree. If it's a tree, we don't have this issue. We don't need to check. But it's a graph, so there is a circle in this, so maybe we become a dead loop. And we create a new node for this old node, and we just map them, put the map, and we will, for the each neighbors, we will append the new neighbors should append the new one, because we use divide and conquer, so we assume, so this function already handle the sub nodes, the neighbors. It can return new neighbors, so we don't need to care more. We just put it like this. That is the DFS. The BFS is like this. We also need a Hashi map, and we need a queue to save the next unprocessed node. So if the queue is not empty, so that means there is some node we need to handle. So yeah, we pop the left. We use is a queue. Is pay attention. It's not heap. It should be a queue. So we just pop left. We the first in and the first out, so we get the first in. So that is the old new, and we put the we because we already put the mapping in the first, so we just get the new, and for the all the old nodes neighbors, if it's not in the map, that means we never touch this node, so we have to create a new node to mapping and put it into the mapping, and we should add the queue because this is the next one. We should handle this. This is the new node, right? So after that, we could add to the new node's neighbor because we already get the new node, the new neighbor. Yeah, so and I return this is a template actually, BFS and DFS template. This is the yeah, so that's all.